This should be pretty quick. I'm just going to give non-technical talk, so it's more of a story. I've been doing a bunch of technical stuff, but I'm a bit burned out. So, who am I? I am trying to get this thing to work. Does it work? Maybe I'll use.
Maybe does that work?
I'll use.
Oh, I don't know.
It was working. It's not full screen, I think. I don't know.
View. So, slideshow or full screen? What do you reckon?
Try slideshow. Oh, there you go. So I'm a software engineer by trade. I'm not a hardware engineer, though I studied a bunch of hardware in school, and I'm very interested in it. And I do write FPGA IP cores and things like that. But once I got into the IP cores and I started looking for something that I can play with, I found OpenRISC, and I just got involved with the software around it because it needed some help. So I've been an open source Linux developer since 2000. I did it as my job. And in 2015, I got involved in OpenRISC after I just felt I need to get back into hardware. And I'm now the maintainer of the upstream ports of Linux and GDB and GCC and QEMU. Just to point out, I'll talk about that later. But I have a full-time job and I have 2 kids, so I don't get a lot of time to work on all of this. It's all just a hobby, but 1 or 2 hours a week. After 10 o'clock when the kids go to sleep, I get to mess around with this stuff in my bed. Yeah. So how many people have heard of OpenRISC? Actually, I got a lot of questions about, oh, what's OpenRISC? How is it different than RISC-V from people? You know Greg Kroll-Hartman? Greg KH, he's now taken over. Linus Torvalds just stepped down from Linux. And Greg is taking over for a short while. And Greg asked me, what's OpenRISC? Like, how is that different than RISC-V? Isn't it the same thing? And no, they're not the same. So anyway, just a background if you don't know, it's OpenRISC is, there's an OpenRISC 1000 architecture, and the OpenRISC 1200 CPU is one of the implementations. And it's a 32-bit core. It does have 64-bit specification, but there's no actual implementations. 32 general purpose registers. It has a delay slot, which is different than a lot of things, which is kind of interesting. And it was implemented in 2000, and it supports Linux and all kinds of stuff. Brief history. So it was actually created in 2000, and it was hosted on this website called OpenCores, which maybe people haven't heard of. It's kind of dead now, but it still is there, and there's a forum there, and people talk about open IP cores. But the founders left and created a company called Beyond Semi, and they just left OpenRISC, and it has been, that's kind of why it's stagnated from 2005 to about 2015. And there have been a lot of people working on it. Julius came along and wrote a new core, but mostly it's been academic stuff. And this is just some more time frames. But recently, out of the OpenRISC community came ORConf and the FOSSi Foundation, which puts on this conference. And there are some websites there. LibreCores, which was talked about. There was a FreeCores, which is kind of the precursor to LibreCores. And then OpenRISC is a website that we run. And I mainly maintain a lot of the stuff on OpenRISC.io. So if you want to find anything I talk about, there's links there. So just a quick, just comparing the different open or soft CPUs. So OpenRISC, RISC-V, and then Neos and microblades. There's lots of others like LM32, and now the Spark is open. But I just wanted to cover these. The Neos and microblades are not really open, I guess. Is the Verilog open? I don't know. But yeah, they all.
The more important is the
ISA for microplay is open.
Yeah, I don't think, yeah. The tool chains are all there. I don't know if you have to license it if you're using it, but anyway, ISA is not open. But OpenRISC and RISC-V are very similar. They all have MMUs, they all run Linux. At RISC-V is recent. It used to say the RISC-V didn't have Linux support. Now it does as of 4.15, I believe. OpenRISC has SMP support in Linux as well as RISC-V. There's not as much silicon tape-outs for OpenRISC as there have been for RISC-V. There might be lots of ones for OpenRISC, but mostly it's been done, without public notice. There's companies that put them in set-top boxes and power controllers, but they don't tell us, and we're not involved in consulting for that or anything. But there are some implementations, I think only about 2 Verilog implementations that exist. You can find those out in my presentation later. I just want to talk about what I did last year. So the documentation, what I said from the last conference in 2016 is we need to work on documentation and upstreaming things. Documentation I haven't got really around to. It takes a lot of time, and I wanted to get everything upstream first and then fix documentation. But OpenCores is still around, but if you do a search for OpenRISC, it's not the first thing that comes back anymore. There's better documentation now. But I have been working a lot on upstreaming. So newlib patches we had about 20 patches that needed to be upstreamed. I cleaned them up and sent them upstream. So if you want to use newlib, the bare metal libc implementation, just take the upstream version. We don't have an OpenRISC version you have to go download and find the code for. Upstream is what you should use. Same with Linux. It used to be that we had hundreds of patches in our repo for an old version of Linux. We didn't have a Linux maintainer because that guy kind of abandoned us and he wouldn't help us out anymore. So I'm now the Linux maintainer, and we've upstreamed all the patches. So if you want to use Linux, just go to the main repo and download that, and that will boot on any OpenRISC core pretty much. And it has SMP support. I think the only thing I didn't upstream was a USB driver because I couldn't test it. But if anybody wants to do that, then feel free. And as part of the Linux upstreaming, I created a new OpenRISC specification, 1.2, which added some updates to the memory model and the definition for how multi-core is supported for OpenRISC. And then GDB was upstream. So there's a lot of stuff that was going on last year, being very busy. Other things is OpenOCD, which I had to use to do a lot of the debugging for, what happened? I was taking too long on my talk. This slide took too long. Okay, sorry about that. Yeah, so, okay. Right, so as I was doing the Linux SMP work, I had to do debugging, as Jeremy was mentioning a lot. The SMP debugging is really complicated, and just GDB, it's not so easy to debug multi-cores. So I had to open OCD support, SMP support for OpenRISC. That hasn't gone upstream yet because those guys didn't look at my patches, but I wasn't too concerned about that. I'll do it later. But QEMU, I added SMP support in QEMU, and I would say now that if you want to do any OpenRISC development, use QEMU. Don't use OR1KSIM. QEMU is a very nice code base, and it is well supported, and it works very well. Has good tracing capabilities and debug and everything. Also, something I've been working on is LiteX, which Tim works on. I helped him get LiteX, OpenRISC core booting Linux on the LiteX platform, which is a Python-based SoC generation system. Any questions?
Is it a LiteX implementation of the OR1K, or is it?
No, it's a black box kind of. They have this Python mygen generator, Python code generator, and it's a black box Mora 1K inside of it. But all the peripherals, the thing that I had to do to get Linux working was the UART driver. So the UART is written in Python, and there was an issue with the Linux driver. We had to write a Linux driver basically for it, and then it booted. We still have to do the network driver, but the hardware had some problems that it couldn't really work in Linux. I think we got the network working too. But yeah, so that took a bit of my time last year as well. But what have I been working on this year? It's basically been this GCC rewrite. So one of the problems we had was GCC was developed in 2000 when the processor started to be developed. But all those guys that moved to that company, Beyond Semi, they didn't sign over. And those guys that moved to the company, they also built the GCC port. They didn't sign over their Free Software Foundation copyright to allow for the code to be upstreamed. And we tried to contact them, and they said no. We work for a company that's selling proprietary OpenRISC cores, and if we sign over our copyright, then we're signing over some of our company IP. So we try to figure out our options, and I just said, let's just write a port. It can't be that difficult. So I did it, and I studied how to write a port for GCC. It's basically two things. There's a machine description file, which is written in Lisp, that defines all your instructions. Like you say add should be your add instruction plus an argument, and it can take a register argument and a memory argument or whatever. And then you also have to define a bunch of calling conventions in C code, and it's just like 3 files basically. But it took a while to figure all that out, and I wrote a dummy port first. I created a new architecture and a new simulator using this guy's tutorial. It's called the GGX CPU, and you go through a tutorial and it shows you how to port your own CPU to GCC. And then I figured out I could probably do it, so I wrote the OpenRISC port. So it started in about February, and then I had an OpenRISC port working to run Hello World by about mid-May. So it was, I guess, about a month and a half, which it was pretty good. But it wasn't working. There was lots of to-do items. The calling conventions for the ABI was not working. The TLS, like thread local storage, C++, exceptions, PIC, shared libraries, position independent code, that wasn't working. Probably all the signed and unsigned stuff was completely wrong. But it can run Hello World, which Hello World is not so simple because it has to use printf, which does memory allocation. So it has the malloc code has a bunch of math that has to be done and a lot of instruction have to be used. So it's quite complicated. A lot of different types of calling conventions have to be supported. And so once that was working, I was pretty confident I could get the other things working. But I ran the GCC test suite. It's something you run, and it has 100,000 tests, and they all run. And I was having about 5,000 tests fail out of 84,000 that were passing, which was okay. A lot of stuff was working, but things would be broken. So I sent a mail out, and this guy, Richard Henderson, replied. He'd been working on OpenRISC a bit for a while, but so just some history of Richard Henderson, what I can find on him. There's this Linux magazine article, We'll Code for Beer. So Richard is known for working on the DEC Alpha Linux, which was an old CPU, a really cool CPU, but it was a bit too complicated and it died out. But basically, the DEC Alpha guys were working on the Linux port in 1995, and they were building their Ultrix their proprietary Linux or Unix version. But the guy who was running the project, Mad Dog Hal, or John Mad Dog Hal, he's a famous Linux guy. He knew that the Linux port was working, but the shared libraries were not supported yet. So the team had been working for quite some time. They couldn't get shared libraries working, the position-independent code. I guess you guys know the DLLs or SO files. So this guy got a mail from Richard, and he didn't know who it was at first, but Richard just said, hey, I heard you're working on shared libraries and you can't get them working. So it was all being done by deck. But Richard said, hey, if you send me some documentation on the alpha compilers, I'll see what I can do. And he said, okay. And then Richard, in 2 weeks, said, okay, they're almost working. Can I talk to your compiler group? And they got Richard in contact with the compiler group, and the compiler guys were like, who is this guy? He's like the most smart guy I've ever talked to. And this was, DEC. And the one thing Mad Dog said is that when this guy called him up, he sounded like a kid. Like, oh, this is a 12-year-old kid on the phone? What? But anyway, the next week, the shared libraries were done. And this guy, he was surprised them quite a bit. So I can't believe it. 15 engineers in 7 years couldn't do shared libraries. And then one guy in 5 weeks did it. So that's who is now helping out with the OpenRISC GCC compiler. So Richard sent me back. I see a few bugs. I'll probably have a look at this in the weekend. So you can just see, like, so on the day later, all of our tests were, and he just fixing all of these in the Git repository, just sending patches, and I was just watching his Git repository and running his code. And so he got all the bugs I talked about. All the to-do items are basically fixed except for a floating point. What's that?
He still follows the 5-week schedule.
Yeah, 5 weeks and for one project. We got Linux booting, and then we were working on, I think he got busy on other stuff, and I started working on a few other, documenting things, getting stuff ready for upstreaming, and fixing a few last bugs, which took about 2 months. But we submitted it for upstreaming, and it was accepted. Yay. So, thank you. So after 20 years almost, it should be done. So there's still a bit of work to do. Accepting means that the Free Software Foundation will allow me to do it once I get an okay, that the code is good. But there's just a few items, documentation, and we want to do multi-libs for disabling some of the special instructions so it can compile on cores that are, have instructions disabled. But that should be done in a few weeks. So that's about it. So upcoming, I want to improve the documentation still, finish the upstreaming for GCC and OpenOCD, get the FPU support working. GDB running in Linux. So currently GDB runs, but it's bare metal. There's a few people asking for it to run. If you're running an OpenRISC CPU with a full Linux distribution, can you run GDB in Linux? That doesn't work yet. And there's some more spec updates for some new instructions that Richard has thought of that we might be adding. But I guess that's about it. I just wanted to talk. Any questions or comments?
Yeah, thank you very much. Julius.
Going back to the simulator. Well, first of all, amazing work. Thank you very much. It wasn't obvious that anyone was ever going to get around to this after Matt Yaz refused to sign his copyright over. So yeah, that's cool. That's really cool. But with the simulator, why are you now more keen on QEMU versus OR1K Sim?
Why QEMU? I guess the reason was that it's better. No, it works faster. Just the code base is very good. It's supported for all architectures, and it has this one feature which is user mode Linux, which basically we do all of our testing. So if you notice MuselWorks, we don't actually boot Linux on the whole processor. It actually will run our binary in QEMU, and when it gets to a system call, it translates that to a system call coming to my local
host system. Yeah,
host system, which really makes it good for testing. And
yeah, cool. How does it go bare metal though? Emulating the bare metal systems.
It has that too.
Yeah,
you could do it. There's a user mode, and then it's called softMMU, which just is the whole bare metal.
Yeah. So all of the GCC suite runs in like a user space environment.
Yeah.
Is that right? Yeah. Oh, cool. All right.
Well, as the official. Hello, that's better. Yeah. So I'm delighted to see ORCsim being retired. It's an old-fashioned interpreting simulator. It's about time it went. On the GDB for Linux, are you talking about native GDB for Linux or GDB running remotely into a remote
native.
Linux? Native, okay. And then a question on the regression testing. Have you tried running regression into either physical hardware or an RTL simulation like MOI?
Not yet, no. I would like to do that, but I haven't.
Oh, maybe I would get off my backside and help with that then.
Anybody else? So OpenRISC is still alive.
Yeah.
Here to stay.
Let me just encourage you to apply formal verification methods. I will just say this, that with just a half an hour, I found a whole bunch of bugs in the UART transmitter, so there's plenty of work still to be done, even in the HDL code.
Okay. Yeah, I mean, one of the things that once all the software stuff is done, I had a few HDL projects I would want to work on, so maybe that would be one.
So I don't think you're out of ideas that what you can do next year.
Probably just work on RISC V.
Goal achieved. We do, there are like code density issues with RISC V that do require a lot of experience. Compiler and the
Not saying
But first finish OpenRISC.
Real practical problem.
Wasn't binutils happy to pay for that?
What is it?
Wasn't binutils happy to pay for that?
Yeah, of course. Many it's not just Western Digital. Like when I reached out, a lot of other companies have pretty much exactly the same issue. Topic of reasons of RISC V do not allow multiple loads.
So thank you everyone. Great time.
Thanks, man.
Thank you.